The electromagnetic spectrum. The electromagnetic spectrum is what we refer to as light. These waves contain everything between radio waves and gamma rays. The only part of the electromagnetic spectrum that we as people can identify without special equipment is the visible light. The visible light that we see makes up only a small percentage of the electromagnetic spectrum. Most of what's left is either radio waves or gamma rays, X-rays, ultraviolet, microwaves, infrared. We can't see these parts of the electromagnetic spectrum, but they are there, and many scientists use them for their research. We identify these waves as either being longer waves or shorter waves. This means that the distance between their peaks is either very long or very short. This corresponds to their frequency or their energy. Something that has very large, long wavelengths has very little energy. But on the other hand, something that's got very short wavelengths has very high energy. Think of it as waves at the beach. The larger distance between each wave, the shorter the impact is on you when you're in the water. It has very little energy. But if the wind is turning up the ocean very rapidly, there's a lot more waves, and you get pushed around quite a bit. Same is true for the electromagnetic waves. Radio waves are the largest waves that we have, and they're approximately the same size as a football field. However, on the other side of the spectrum, the gamma rays are only as big as an atomic nuclei. At the bottom of this picture, you can see the visible light that we have all around us and experience every day. The visible light only exists between 700 and 400 nanometers. That's the only part of the spectrum that we can see. But how do we use this spectrum in our study of chemistry? Well, by using the spectrum of light, we can create fingerprints of stars based on the elements that they contain. This is called spectral lines. Spectra coming from the light spectrum, and lines because they have narrow bands that form with these elements. So each element contains electrons that absorb the energy given off by that light, leaving that color black in the spectra. For instance, let's look at the spectra in front of us. If we were to take a look and we wanted to see if there was hydrogen in this star, we would notice that there's black bands in the purple, blue, green-blue, and red spectra, showing that hydrogen is present in this star. If we wanted to know if there was oxygen, we would look at the red and orange, and if they were missing, we would know that they are there also. So how does someone typically determine whether or not there's an element in that star? Scientists don't memorize them. They have tables. So let's take a look at one. Here's an example of what a scientist would be looking at. At the bottom, you see that there's a mixture. This is what a scientist has in front of them when they're looking at the chemical composition of a star. They have 4 examples showing what could possibly be in this star. It's up to them to determine whether or not these elements are in there to begin with. So let's take a look to see if we can figure it out. As you can see, there's 4 elements that it could possibly be. Element A, D, X, and Z. Let's see if we can begin with the first set of lines and choose which element or elements could be in it. The line all the way at the left is where you should start, and then work your way to the right. As you can see, the first line only matches with element A. No other element contains this line. So element A has to be in the mixture. Let's move down to the next set. These 2 lines have to come from element A and element D. Elements X and Z do not contain lines in this section, so it cannot come from any other source but elements A and D. If you look at the next 2 lines, we have a little bit of question here. It can either be element X or the 2 lines from elements A and D. Look carefully and try to figure it out. Pause the video and see if you can figure out the rest of the lines as well. So did you figure out the lines? If you looked at that third set of lines by 500 nanometers, you would automatically say it has to be element X. But if you take a closer look at the spacing between the lines, you'll notice the lines in the mixture are smaller than the lines in element X. So it has to be coming from elements A and element D. So element X cannot be forming these lines. As you move further and further down, you can eliminate element X completely. None of the lines that are formed in the mixture match with any lines in element X. So this mixture contains elements A, elements D, and element Z. This is what a scientist does when looking at starlight and trying to figure out what elements could possibly be in that star. We also have the rovers on Mars doing the exact same thing with soil samples, trying to figure out if there was ever life on Mars. So what have we learned? We learned what the electromagnetic spectrum is, how we perceive the spectrum, and how to determine and understand spectral lines.